In this video, we're going to go over solutions to the questions and problems from test 2. Okay, number 1, in terms of units, which of the following statements makes sense? If it makes sense, circle yes, otherwise circle no. So, A, the electric generator put out 750 watts of energy in total over the course of the day. So the answer to that is no. Watts is the unit for power, not energy. It would have to have been joules or some other unit of energy, like kilowatt hours or something like that. But watts itself is a measure of power. That might have been how the rate at which the electric generator was putting out energy. But this was clearly the accumulated total amount of energy over the course of the day. That's energy. That would have to be measured in joules. B, the pushing force did 50 joules of work. That's fine. Forces do work, and work is energy transfer, so it should be measured in joules. Of course, the force the strength of the force itself would be measured in newtons, but that's not what this is talking about. Forces themselves are in newtons, but forces do work, and that's what this is. And then finally, the static friction between the object and the table has a magnitude of 5.8 newtons. So here's an actual force and the magnitude of it. And yeah, that makes sense. That's measured in newtons. So that would be yes. Number 2, if a cannonball is shot from a cannon and undergoes projectile motion, its momentum at all times will remain constant by the law of conservation of momentum. So what you have to remember about the law of conservation of momentum is that it applies to systems that are isolated, no external forces. So now this problem is talking about its momentum. We're talking about the cannonball itself. So that's the system. Is that an isolated system? Or are there external forces? And we immediately realize, oh, it's not isolated, because gravity is, of course, the major external force. You might also include air resistance, but I know sometimes that we ignore that or pretend it's not there. But even without that, it's gravity. Gravity is an external force that is acting on the cannonball. The cannonball is not an isolated system, and we would not expect the momentum of the cannonball, therefore, to stay constant. And in fact, it doesn't. It's faster at the beginning when it's shot. It slows down at its peak, and then it starts coming back down and it speeds up again. So its momentum definitely changes. So yeah, this would be false. Number 3, which of the following is a means of transfer of energy? So this was one of our Socrative quiz questions that I included on the test. There are 6 means of transfer of energy that we talked about, but we really have only in depth talked about one, and that was work. Kinetic, internal, and potential are all forms of energy that an object has, but those aren't transfers of energy. And power, of course, is a rate of transfer of energy, but it is not the transfer of energy or the means of it. Work is the means of transfer of energy that we have been concentrating on in the chapters on energy. Number 4, are the following forces conservative or not? Answer yes or no for each. So conservative means that they can store energy. In other words, there's a potential energy that's associated with them. And we learned 2 conservative forces. Spring force. So the spring force is definitely a yes. Right? We have a formula for the potential energy of spring. US equals 1/2 kx squared. And gravitation. UG is mgy. So if you have a potential energy, it means it's a conservative force. Kinetic friction is no. That was definitely a non-conservative force. That force, friction, steals mechanical energy, doesn't conserve it. It steals it and sends it into internal energy. In other words, things heat up or make a sound or something like that. Okay. Number 5. When an object is dropped from a height and air resistance is taken into account. Okay. So option A says the object has a constant downward acceleration of 9.8 meters per second squared. Well, that would be if air resistance was not taken into account. That would be pure free fall without air resistance. So it's not that. B, the object has a constant downward acceleration, but the magnitude is less than 9.8 meters per second squared. Well, that's a little bit more plausible, but it's not true that it's a constant acceleration when air resistance is taken into account. The acceleration is changing the whole time. C, the object drops at a constant speed the entire time. That's definitely false, because if we just drop the object, it starts with a speed of 0. So if that's going to be a constant speed, then that means it's just going to float there and not move. We know that the speed increases as it drops. D, the object accelerates at first, but then its speed levels off and it falls at approximately a constant speed. So it does get to a constant speed after a little bit of acceleration, a period of acceleration. And that is the answer. So we reach that terminal speed. That's what this constant speed that it eventually reaches is. It's this terminal speed that we've talked about. So if you think about over time, the speed starts at 0. It's going to speed up as it drops, but then as air resistance increases, it's going to level off. And there's the terminal speed. So yeah, D is the right answer here. We will stop the video here and pick up in part 2.